This example comes out of section 8.1. The section is called Understanding Logarithms, and to start off with, we'll have a look at something we actually would have seen in chapter 7, which is just some solving exponential equations. The first one is 10 to the x equals 100. Because 10 and 100 can be written as powers of the same base, we could solve this one using algebra. Say 10 to the x equals 10 to the 2, and so we know that x must equal 2, and we can confirm that either graphically or just by putting in 2 as x for the original equation and find out that that is true. The second question is a little bit different because 60 is not a power of 10, and so I don't know exactly what this answer is. So at this point, without knowing about logarithms, my choices would be to solve this thing graphically, say y equals 10 to the x, y equals 60, look at the exponential growth function in the horizontal line and find out where they intersect, and find out that x equals approximately 1.78. Not a nice number. Decimals go on, but that 10 to the power of the exponent of 1.78 is approximately equal to 60. Later on in this chapter we'll be able to do that question in a much different way, and in fact a faster way, because we'll be able to use logarithms to do it. To go along with this little introduction, I just also wanted to mention something about exponential form and logarithmic form. Exponential form we've seen before, y equals some base to the exponent x. If you were to change that directly into logarithmic form, you have log base c of y equals x. Now, we haven't tried that at all yet, but one thing I want you to notice is that the base in the exponential form is the base in the log form, so that is one thing that they have in common. The exponent in the exponential form turns out to be the answer in the logarithmic form. So if we look at an example of an equivalent expression, if we have 9 squared equals 81, because we're very familiar with exponents, we could see that 9 squared equals 81 makes sense to us. The equivalent log expression says that log base 9 of 81 equals 2. These two equations, although they look very, very different, actually mean the exact same thing, that 9 to the exponent 2 is equal to 81. You might wonder initially why you'd have two ways of writing that, but as we go along through the chapter you'll see uses of logs, and there are actually quite a few of them. To write another one of these, just for some practice, 5 cubed equals 125, so log base 5 of 125 equals 3. 10 squared equals 100, log base 10 of 100 equals 2. Now this last one is something you could actually check very quickly on your calculator, because the log button that you have that's right beside the 7 on your TI-83 or 84 calculator is log base 10. So if you just punch in log 100, you'll get an answer of 2. Much the same way that if you punch in log of 1,000, it will tell you that 10 to the 3 equals 1,000. So if I do log base 10 of 1,000, I will get an answer of 3. And these last two are what we call the common logarithm, and we will see base 10 more often than we see any of the other bases.